Hello folks, we are back with yet another video. It's not the previous application that we were doing. We finished now. By now we have finished the rate measurer application, and we have also finished the increasing decreasing applications. Both are very important. And of course increasing decreasing is more important. Now we'll be switching over to the next application, which is tangents and normals. Now tangents and normal, off and on, it gets for the CBSE board exam, they keep on deleting and all that. As of now it's a deleted portion, but we'll do it. Why? Because it's important from the JE application point of view and all that. So anyhow, knowledge point of view, yes, it is important, so we'll be doing it. So this is what we are going to do, tangents and normals. That's the new application that we are going to do, and it is pretty easy actually. So we are not, it's not nothing great. We've been doing this for quite some time. Tangents we have done in the 10th standard. We know that for any curve, if we at a certain point we draw tangent is a line which touches that curve at a single point. So this is a tangent. This is for any curve. This is what we call as a tangent, and anything that is perpendicular to that tangent is what is called as a normal. So that's it, tangent and normal. So in this exercise we'll be doing, we'll be finding the tangent and normal at a set point. They will tell you a point and we will find it out. Now this is a geometrical aspect. The algebraic aspect is how do we find it. If we that means they will give us a curve y equal to a certain thing. In order to find the tangent, we will find out dy by dx. If we find out dy by dx, that will help us to give the slope of the tangent. It will help us to give the slope of the tangent. And since we know that tangent and normals, they are perpendicular to each other, we can use a property that which we studied last year, that when there are two lines which are perpendicular to each other, such that if one line has got slope m1 and the other line has got slope m2, then in that case we know that m1 into m2 is -1. All this together we'll be using in our upcoming exercise. It may or may not make sense. It's okay. If it doesn't make sense, no problem. As we take the problems, it will be very clear to you. It's not so difficult. The application is quite easy. And as of now, of course, as I told you, it's a deleted thing. But then JE is always there. So we have to know it. So let's get across directly doing it. We are coming to exercise 6.3, the problem number 1 day. Let's see what it says. Find the slope of the tangent to the curve y equal to 3x cube minus 4x at x equal to 3. Yeah, it is y equal to 3x raised to 4. Yeah. I hope the curve is correct. Let me get it cross-checked. Y equal to 3x raised to 4 minus 4x at x equal to 4, they say. They ask us to find the slope of the tangent. Slope of, as I told you just some time back, that in order to get the slope of the tangent, it's enough if you do dy by dx. Now find out dy by dx, and that's the slope of the tangent. In order to get the slope of the tangent, we only need to algebraically find out dy by dx. So let's find out. Quite simple, isn't it? Dy by dx. Derivative dy by dx. What will it come? 3 into derivative of x raised to 4 is 4x cube. N x raised to n minus 1. By now it's thorough for us. And derivative of x is 1. Like that, you have the derivative. 4 common. 3x cube minus 1. Now we're taking 4 common. We saw the 4 common, so quickly we are taking it out. That's it. This is in terms of x. But they ask us to find out the slope of the tangent at x equal to 4. So let's make the substitution. 3 times 4 cube minus 1. Let's find this out. 4 4s are 60, 64. 64 into 3, what is it? 12, 89, 192 minus 1, which is 4 into 191, which is 4, 764. So the required slope, if you want to write the answer. Of course, this problem as such, there are very few chances that it will come for a big question. It can come for a 1 mark MCQ, etc. So there, of course, the steps are not at all significant. You just have to get the answer if it is like that. 2 marks, we require a little bit of steps. So that's very easy. So we can quickly move to the second problem. Same question, like nature is the same. Find the slope of the tangent to the curve y equal to x minus 1 by x minus 2 at x equal to 10. X is not 2, they have ensured, and x is at x equal to 10. So they give us a curve. The curve is y equal to x minus 2 by, x minus 1 by x minus 2. Yeah. So let's proceed now as usual only. Dy by dx we will do, and then we'll find out. So, but this is a quotient. So we'll apply the quotient rule. Quotient rule we all know. So let's apply it. Dy by dx. We are applying the quotient rule. X minus 2 as it is, derivative of x minus 1. Then x minus 1 as it is, derivative of x minus 2 by x minus 2 the whole square. X minus 2 as it is, derivative of x minus 1 means derivative of x and derivative of 1. Derivative of x is 1 and derivative of 1 is 0. So that is 1. So also x minus 1 as it is, derivative of x minus 2, x, the derivative is 1 and 2 derivative is 0. Like that, this will be 1. Let's take what comes. X minus 2 minus x plus 1 by x minus 2 the whole square. X can cancel, minus 1 by x minus 2 the whole square. That's it. That is dy by dx. But they have asked us to find the slope of the tangent at x equal to 10. So let's find that. At x equal to 10, which means minus 1 by 10 minus 2 the whole square, which is 8 square. 8 square is 64. Minus 1 by 64 is the required slope. Yeah. So let's conclude. Required slope. That's about it. Quite simple. Hardly anything. So we move to the third problem. Find the slope of the tangent to the curve y equal to x cube minus x plus 1 at the point whose x coordinate is 2. Almost same. Yeah, it's a polynomial function y equal to x cube minus x plus 1. I hope it's correct. Yeah. Minus x plus 1. They ask us to find the slope of the tangent to the curve at the point whose x coordinate they give it as 2. So, yeah, x equal to 2. Same thing. So, let's do the same. Dy by dx. Slope of the tangent. Yeah. Let's do the slope of the tangent dy by dx. Get the derivative x cube. The derivative is 3x squared. Derivative of x is minus 1. 1 is a constant, no derivative. So that's your dy by dx, and they've told us that it is at the point where the x coordinate is 10. 10, let me cross check. Sorry, x coordinate is 2. 10 was the previous one. Yeah. So 3 times 2 squared minus 1. 2 2s are 4, 4 3s are 12, 11. Isn't it? That's it. Yeah. Can we take the fourth one also? Let's take if time permits. I mean, the place and time permits. Let's take the fourth one. Find the slope of the tangent to the curve y equal to x cube minus 3x plus 2 at the point whose x coordinate is 3. Very identical to this, only a little bit of change. So they say y equal to x cube minus 3x. I'll check this. The x cube minus 3x plus 2. And they say that the x coordinate is 3. So, like before only, let's do dy by dx. It is 3x squared because x cube derivative is 3x squared and x raised to n minus 1, and minus 3x minus 3 as it is, derivative of x is 1. So, if you want, we can take the 3 out. X squared minus 1. They say that the dy by dx, it is at x equal to 3. So, let's have that. 3 squared minus 1, 9 minus 1, 8. 24. Right? The answer is 24 in this case. Yeah, that's about it. Since the board is filled, maybe we can stop this video here, and with the next few problems we can meet in the next video. Very simple. These problems, of course, they are not, they will be asked for only that much marks. They are not like the higher mark questions, lower mark questions. That's all about it. We meet in the next video. Thank you.